Good morning, pilot teachers and students. Good morning, class.
Good morning, Mr. Sarah.
Okay, thank you. You may sit. Right. Okay. In our last lesson, we went through our discussion. We already had a look at the force of gravity, and you saw that that is a force that always makes object fall towards the center of the earth. Now, in this lesson, we'll be also looking at the force of gravity, but how they have to keep object balanced, or let's say in equilibrium. So the topic for today will be forces, and this time we are looking at the center of gravity. Okay, quickly have this information that let's say write the topic, and then I will give you the notes that come after that. All right. Okay, can somebody give us the explanation or your definition of center of gravity? Sulaiman. Okay, pass him that.
Center of gravity is what keeps an object balanced, so it doesn't move from side to side.
Okay, right. According to that definition, center of gravity is whereby forces or different forces are acting on an object at a certain point, right? Now, simply you'll find that for this case, when the force of gravity pulls in an object, it seems to act through a same point on the object, independent of how the object is held, right? This point is called the center of gravity. So quickly have this definition done. All right, I will now give you the next. Okay, looking at this, for example, this is in a straight flight. All right, the forces that will be acting on this plane is simply the thrust that is provided by the wing and also the lift. And then you find a track which is also on that opposite. Now for the weight, it is always going down. So the center of gravity will be existing somewhere here. He said it, that is, okay, looking on the same, okay, you find the axis here, right? One of these lateral axis, and then you have longitude axis and the vertical axis. So that point is somewhere in here, okay, the center of gravity. Right, looking at, okay, that is example number 2. And you find this especially in some the trucks and buses. You will find that, right, especially I think a bus will have a low center of gravity because it is quite low. It can balance itself. For this one, it has a very high center of gravity. And okay, modern types of racing cars with the old type, you find that especially this one is quite low, and the wheels are quite flat, and the diameter is quite large. So therefore, it can balance itself quite well, meaning that it has a low center of gravity. While this one it is quite high, okay, because of the wheels, okay, the thinner wheels. Therefore, the center of gravity will be quite high. So the forces acting at the point will be quite high. Okay, that is why we call it a. Right, looking at the equilibrium of this object, you'll find that if you stand up a cone like this flat, or the base of that downwards, you'll find that it is in stable equilibrium, and that one will be unstable with that one which is neutral, meaning that if you have to roll it somewhere on a table, it will rest at any point. While this one, it is unstable because the moment you let it go, it's fall down. And this one, you can move it, okay, meaning that it is stable. You can move it while it is in that same position. You can move that around. This one, you cannot move that while it is in the same position because it is unstable and can fall down. While this one, you can move it, but it can rest on any one side of this ball. So quickly have only this information done. I'll give you the activity. Okay, I will give you your activities. Pilot teachers, you can ask the students to go through, copy these activities, and then after that you can ask for the answers from the students. Okay, so the model students, you can quickly go through now and then have your questions. All right, question number 1, explain each of the following. All right, trucks are less stable when they have to carry a load, and B, you find that a double deck bus is less stable when it less stable than a single decker bus. Okay, that is for question number 1. All right, we will now give it, that is the next two questions. Right, before you go on to, please look up, I will explain to you using this diagram that I've just put on the board. Right, if you have to look at this, right, let's say there is a car that is moving along a road, straight road. Right, you will find that the center of gravity will be existing on these 2 points, and they are quite equal. That is why the car will be at equilibrium, or it will balance. However, if let's say this car is put on a slope, okay, if that is not steep enough, you'll find that more of the force will be acting on this wheel or tire, and less will be up here. However, if the steep or the slope is quite steep enough, you'll find that the weight is now on this, and you'll find that this one will have to orientate in order to balance itself out. So this one will be coming or turning that way around. Why? Because most of the weight has converged or fall on this tire. Okay, because we have the center of gravity which is here. Okay, in here, center of gravity is also here, but you have less here and more is here. And in here they are quite equal on each part of those tires. Okay, so you have finished copying those two questions. I'll give you the next question. That is the last. Okay, you can go through quickly. I'll give you a few minutes to quickly discuss those questions. Write them down. I'll come back to you. Right, as you were listening, right, for example, if I have to have this stick here, right, the center of gravity for this one, especially when I'm holding this, would be somewhere there. You see the stick, it's not falling off because the forces will be able to balance each other out, right? If that is quite great, if one force acting on this stick is quite large enough, you will obviously find that the stick will be falling off from the hand. So the point at which all forces will be acting in order to make one thing stable is called the center of gravity. Right, just like this one, the stick. This is the center of gravity. It acts, all the forces converge on this small point here. That is why it is balanced. If one force is greater on one side, probably this way, you find it falls over. All right, quickly go through and then do those questions. Discuss them. Yesterday's question, who were those people who were responsible for the questions I asked yesterday? 1 and 2. One of you, who was it? Jolene. All right, you will do the first one, question A, 1A, B, C, and D. A, B, C, and D. Mark, Alan. All right, you get ready for question number 5. 2. Question 2. Okay, now to that last question. For each of these, explain where you will find or where the center of gravity will exist in following things. You have a ruler, a disc, and then a sphere, a cube, rectangular card, and also a ring. 2, 3, and 4. 1, 2, 3, 4, 5, and 6. Okay, since 6 of them. 1, 2, 3, 4, 5, and 6. Just explain, okay? All right, you can continue with the discussion. I'll give you only a few more minutes. A few minutes, and then I will ask you to come up and then, or stand up and then give your explanation. All right, we will now go through the corrections to those questions. Question number 1 will be on this side. We'll have question 1, 2, and 3. Or let's say 1, 2, 3, and 4. Okay. It should not be question 1, but it is question A, B, C, and D. Okay. So we'll have this side to go through those questions. The first one should be Saurang. You will do question number 1, and question 2 will be Jolin, and third question that is question C. Okay, not third question, but question C will be Kimberly, and lastly Michelle. Okay. All right, pass her that microphone. Where is it? Here. Okay, quickly. Stand up. You go through your question quickly, and then we'll move on. Or yours is question, okay, A. Jolin, you do A, and B will be Soaring. All right, stand up.
Trucks are less stable when they carry a load because the loads on trucks are high. They have a high center of gravity, causing them to be less stable.
Okay, very good. So when trucks are able to carry this load, you find that there is a load quite high. The force that will be acting on one is quite, so the center of gravity will be quite high. Okay, very good. So we'll go on to the next question for Saurang.
The weight force of the double-decker bus is greater than the other forces acting on the bus, which cause the bus to have a higher
Okay, so you heard what she said. Simply, a double decker bus will have more center of gravity, okay, because it is quite high. And when it carries a load, you'll find that passengers will be on top rather than having a few which is almost closer towards the ground level. So that is the reason why we'll have double decker bus which will have more center of gravity. Okay, very good. Okay, we'll go on to the question C.
Because the base is flat and wide, it balances the glass. Therefore, the center of gravity is less.
Okay, that is the same concept you have when it is full. You have lots of water in that glass, so more weight is converging, or the center of gravity is quite high because you have more weight. Right, the last one will be Misha.
An electric lamp has a heavy base so that the center of gravity is within the base, which makes it more stable.
Okay, good. So electric lamps should have a flat base in order to make this center of gravity quite small so that this lamp will be more stable. Okay, that is D. Okay, we'll move on to our second question. That is Alan.
Racing cars in the past, racing cars have been changing their shape over the years, because in the past, racing cars have been manufactured and shaped in a way that increases drag, and also the air resistance is much more lower, and the tires, which are made much thinner and closer together, which causes a high resistance. And when the car is in full speed, even if it wants to turn, then the vehicle collapses, causing accidents. So nowadays, racing cars are built in such a way which the body is shaped in a way which reduces drag and reduces high resistance of wind across the body to enable the car to travel. And also the wheels are made much wider and much further apart to stabilize the center of gravity, to decrease the number of accidents occurring on the speedway of the racing cars. So thank you.
Right, very good. His explanation is based on resistance as well as the center of gravity. Racing cars have changed over the years, because you find that in the past you have racing cars which have more thinner wheels, okay, very thin. But today you have racing cars with flat, okay, large diameter wheels, so that it can withstand any the center of gravity. Whenever it is turning around a corner or something like that, it can simply keep itself equilibrium when it is turning. That is one. And also you'll find that it has reduced some kind of air resistance. The face is quite sharp, and that it can always go faster without any resistance from the air. Okay, very good. Okay, we'll go on to the last questions. Okay, we'll have 6 people just to stand up, explain where you will find each of those. Okay, number 1. A will be Numa. Sorry, Joe. Joe, you will have to go for A. B will be Sulaiman. C, Samuel. D will be Malcolm. Ume. Okay, Ume. And last will be Isaac and Nathaniel. Okay. Right, stand up quickly, answer your question.
The center of gravity on a ruler is simply just...
Okay, show that where you will find the center of gravity on the ruler.
The center of gravity is simply just in the middle of the ruler. For example, this is a 24 centimeter ruler. The center of gravity will be acting on the 12 centimeter mark.
Okay, very good. So you have a ruler there, and the center of gravity will be in the middle and in the center of the ruler. Okay, very good. So second a sphere?
In a sphere, the center of gravity will be in the center.
Okay, it can be at the center of the sphere. Any point, whether you roll it, must be always at the center of the sphere. Okay, Samuel?
Center of gravity in a disk is
Okay, center
the
of
middle of
gravity
the
will be
disk.
at the center of the disk. For a cube,
center of gravity of a cube is found in the center of the cube.
okay, very good. So he has given us a cube, and the center of gravity will be found in the center, in the middle of the cube, but in the center of the cube. Okay, Nathaniel.
Center of gravity of a rectangular card will be found in the middle because the rectangular card is a stable equilibrium.
All right, the rectangular card, this is something which is almost rectangular, or if that is, okay, so the center of gravity will be somewhere in the middle here, but right in the middle of that where you divide, okay? So the center of gravity will be in the middle. Okay, last one.
The center of gravity of the ring will be in the middle of the ring.
Okay, if you decide to hang ring up on a nail or something like that, you'll find that it will be hanging down. So that is the center of gravity. It exists at any point on the ring. Okay, so it can be the center of the ring. Okay, so that brings us to the end of the lesson. You've gone through and had a look at the center of gravity. Center of gravity is simply the point where all the forces are acting in order to keep it equilibrium or at balanced state. So we have seen some of the examples on center of gravity. Pilot teachers, you can also inform that to the pilot students. In our next lesson, we'll be going through, and then we'll be discussing on the action and reaction force. So you can also ask your students to go through and then research or find out more on action and reaction forces. Okay, that is the end of the lesson. Right. Our keyword for today will be the center of gravity. Okay. Once again, good afternoon, pilot teachers and students. Good afternoon, class. Thank you. You may leave for the next lesson quickly.